Okay, for Algebra Lesson 6.3, we are now moving on to solving systems by elimination. So we've already used systems of equations, we've already solved systems by graphing and by substitution, but today we're going to be eliminating one of the variables, and that will help us find our point of intersection. So part one says solve using a system using adding. So we're going to use elimination to find the solution to these two equations. So 2x plus 5 equals 17 and 6x minus 5y equals negative 9. Now what I want you to notice is we've got a plus 5y in one equation and we've got a minus 5y in the other equation. So we can actually set these two equations up just kind of like kindergarten adding. So I'm going to set one equation on top, 2x plus 5y equals 17, and the other one just right below it, 6x minus 5y equals negative 9. And just like back when we were in first grade or kindergarten, you would draw a line like you're doing 1 plus 1 equals 2, and you would draw a big plus sign off to the side. And let me tell you why I chose to put addition instead of subtraction. If I were to subtract, each of these terms would get subtracted. Each of these terms gets subtracted, and 5y minus negative 5y would not eliminate it. And the whole point to elimination today is to be able to eliminate a variable like we can by adding. So take a look at this. Positive 5y plus negative 5y are opposites. That means they cancel each other out. They would be 0. So if you added it, it would be 0. So let's take a look at what we have if we add 2x plus 6x. Over here you would have 8x. What about if you added 17 plus negative 9? Let's check and see. 17, oops, I forgot to clear that. 17 plus negative 9 is positive 8. So just like that, we almost have what x is. You would divide both sides by 8, and x equals 1. So just like that, we have half of our answer of where these two systems would intersect. They're going to intersect at 1 for the x coordinate, and we don't know why. So I'm sorry, but this really quick method of elimination only gives you one of the two variables. So we still need to use x, which equals 1, and go plug it back in for one of our equations so that we can get our y. But at least the elimination helped us to get one of the variables super quick. So now that I have x equals 1, I'm just going to choose any of my equations. It doesn't matter. I'm going to choose that first one, but really you could use the second one if you want. It doesn't matter. And I'm going to rewrite 2x, except not x. I'm going to use 1 for x because now we know what x is. We solved for it. Plus 5y equals 17, and I'm just going to solve it just like you would any normal equation. 2 times 1 is 2. You're going to subtract 2 from both sides. 5y equals 15, divide both sides by 5. I've run out of room, but y would be equal to 3. So we have now solved my x coordinate is 1, my y coordinate is 3, and that is how to solve them by elimination. You find two of the variables that you can eliminate by adding. Okay, so let's try this one. If I were to line these up one right underneath the other, I'm just going to put the 3x minus 4y equals 5 right underneath this one that was already there. And again, you kind of have to decide, am I going to add or subtract? What would make the 3x, the negative 3x, and positive 3x eliminate? The only way to get those to eliminate is by adding. If I were to subtract, it'd be negative 3 minus 3. And negative 3 minus 3 is not 0. It's negative 6, so they would not have eliminated. So I'm going to have to add. So when I add, these eliminate. When I add negative 3y plus negative 4y, I get negative 7y. And when I add 9 plus 5, I get 14. All right, just like that, we're almost done. Divide both sides by negative 7, and it would be negative 2. So half of my coordinates of my solution, my y coordinate, is solved because we just got y equals negative 2. So now that I know y equals negative 2, I'm going to grab either one of my two original equations. It doesn't matter which one. I have a habit of picking the first one. but it doesn't matter which one I pick. And I'm going to go rewrite it. Negative 3x minus 3, not y, but times negative 2, because that's what y is. So negative 2 equals 9. Sorry, my dog is deciding to bark right now. Okay, go ahead and solve the equation. Yep, that's Rocky. He sees another dog outside. He's very excited by. These elimination problems are not impressing him right now. Negative 3x on both sides equals positive 3. Divide both sides by negative 3. And you have that x equals negative 1. And now you're done. So negative 1, negative 2 is your answer. Okay, both of those were examples of how you would add to eliminate, and now we're going to move on to talk about how you would subtract to eliminate. This is a multiple choice. It's a big word problem, but let's go over it real quick. The theater club sells a total of 101 tickets to its first play. A student ticket costs $1, and an adult ticket costs $2.50. Total ticket sales are $164. How many, we're going to probably find out how many of each ticket were sold, but then it really just wants to know how many student tickets were sold. So it's kind of already got this equation set up for us. It's saying adult tickets, that's what the A stands for. Oh, because it tells us here A is adult tickets, S is student tickets. So adult tickets plus student tickets equals 101 tickets. And the reason we know that is because it told us. Okay, but then let's do the money plus money equals money. $2.50 times the number of adult tickets plus, this is a $1 per student ticket because it's $1 each for student tickets, but they just have it hidden invisible. That's okay. $1 times student tickets equals a total of $164. So those are my two equations. And using them, we can go ahead and line them up just like we would in kindergarten or first grade. So let's do that. Let's do A plus S equals 101. And then let's do 250A or 2.5A plus S equals 164. Okay, remember, just like we did earlier, we're going to draw a big line. And before I would do a plus sign, but let's look and see if that plus sign would make us eliminate anything. This 1A plus 2.5A would not eliminate. This 1S plus 1S would also not eliminate. It would be 2S. And that's a problem. I need one of these to eliminate. So I'm going to choose to subtract because I know that 1S minus 1S would be 0. Those will now eliminate because I'm subtracting. So that means I have to subtract all these other parts as well. So 1 minus 2.5. 1A minus 2.5A equals negative 1.5A, and that is equal, bring down your equals, to this minus this. So if you choose to subtract, you have to subtract on all the parts, all the different terms. Okay, it's negative 63. We're still just about done though. All we have to do to get A by itself is divide both sides by negative 1.5. Oof, I'm going to have to write it over here. A equals whatever negative 63 divided by negative 1.5 is, which is 42. So that means we sold a total of 42 adult, remember A represented our adult tickets. So 42 would be the answer. B, if we were asking how many adult tickets, but instead they're asking how many student tickets. So we don't know that one yet. But we do know that the total number of tickets was adult plus student equals 101. And we now know that the adult number of tickets is 42. So what we're looking at is 42 plus we don't know student tickets, but we know there was a total of 101. So you could also just do this in your head and subtract 42 from 101 or just in your calculator, but this is how to set it up. 101 minus 42 equals 59 student tickets left, or were sold, sorry. So actually our answer is C. All right, turn it over to the back. Let's do part 3. Not only will you sometimes be able to eliminate by adding or subtracting, but sometimes you can eliminate by multiplying. So let's take a look at these two equations at the top. Negative 2x plus 15y equals negative 32, and 7x minus 5y equals 17. So I can't just line them up like I would back in elementary school and add or subtract, because none of these will eliminate. But what I notice is 15y and negative 15y, if that's what it was, would eliminate. So how do I make this negative 15y? What you could do is you could take the whole thing and multiply it by 3. Okay, you can't just take the middle term and multiply it by 3, but you can take the entire equation and distribute all 3 parts by 3. So let's see what we would have then. We would have 21x. We would have our minus 15y, which is what we want. And I don't know what 17 times 3 is. 51. So if you multiply all 3 parts, now I've got an equation that's a positive 15y and my new equation that's a negative 15y. And I can go ahead now and line these up and eliminate. So I'm going to just slide this one over. So I've got 21x minus 15y equals 51. And now let's decide if I need to add or subtract. I'm going to eliminate positive 15y and negative 15y by adding. Again, if I subtracted, that'd be 15 minus negative 15, which would actually be positive 30. It wouldn't be 0, and I want it to be 0. That's how to eliminate. So now that I'm adding, they will eliminate, and I have to add all the other terms. So negative 2x plus 21x is 19x. And negative 32 plus 51, there we go, is 19. Okay, great. Divide both sides by 19. It looks like x is going to be 1. All right, my x-coordinate's 1. Now, here's what I want you to know if my x-coordinate's 1. I mean, this happens anytime. I can take my x for 1 and I can plug it into the first equation for x if I want, the second equation for x if I want, or the equation that I multiplied by 3. It does not matter which one you pick when you're trying to now solve to get our y. I have a habit of just picking the first one, so I'm going to do that. But again, you could pick any of those 3 equations and you would get the same answer for y that I'm going to get. So negative 2 times not x anymore, but 1, because that's what x was, plus 15y equals negative 32. All right, that would be negative 2. So you would add 2 on both sides. 15y equals negative 30. Divide both sides by 15. I'm running out of room, but y would be equal to negative 2. So our entire answer would be 1, comma, negative 2. All right, let's try the next one. So negative 5 and 3, I can't just take 3 and double it to get negative 5. That won't work. But I can take negative 2y and triple it, and it would be the opposite of positive 6y. So I'm going to take this first equation and I'm going to multiply the whole thing by 3 and line it up underneath my other one. So that would be 3 times negative 5x is negative 15x. 3 times negative 2y is negative 6y, and that's why I'm doing it, because now I have opposites that will eliminate. And then don't forget, 3 times 6 is 18. If you multiply, you have to multiply all 3 terms. And then I'm going to choose to add, because that's the only way that these opposites will cancel out, which means eliminate. So if I'm adding 3x plus negative 15x, I'd get negative 12x. 6 plus 18 is 24. Divide both sides by negative 12. X equals negative 2. So we've got half of our answer. Now that your x-coordinate's negative 2, I can take it and plug it into this one, or the one I multiplied by 3, this one. Doesn't matter. So I'm just going to choose my original one. Negative 5 times not x, but times negative 2, because that's what x is, minus 2y equals 6. All right. Negative 2 times negative 5 is positive 10. So I'm going to subtract 10 on both sides. Negative 2y equals negative 4. Divide both sides by negative 2. Y equals positive 2. All right. Let's look at part 4. This is when the only way to eliminate is by multiplying both equations by different things. So, or by sometimes by the same thing. So let's say I want to eliminate either 4 and 3x or 2y and 3y. So I can't just double 3y because that would be 6, or sorry, double 3x because that would be 6x and that won't eliminate. And I can't just double my 2y because that would be 4y and that also won't eliminate. But I can choose to multiply each equation by two different things. So maybe I want to make both of my x's equal to 12x and negative 12x so that they would eliminate. So in fact, let's just say I want to make them both equal to just 12x. So I would need to multiply these. If I want 3x to become 12x, I would multiply all the terms by 4. And if I want this 4x to also be 12x so that I can eliminate, I would need to multiply all these terms by 3. So let's try this first one first. So I'm going to distribute the 4. 4 times 3x is 12x. 4 times 2y is positive 8y. And 4 times 1 is just 4. Okay, let's look at the second equation. 3 times 4x is 12x. 3 times 3y is positive 9y. And then 3 times negative 2 is negative 6. All right, when you're choosing what to do, you want to eliminate. So if I chose to put plus, would 12x plus 12x be 0 and eliminate? No, it would not. It would be 24x. So I have to subtract in this situation. 12 minus 12 is 0, and therefore those eliminate. So be sure now you're subtracting this part and this part as well. So 8y minus 9y is negative 1y. And 4 minus negative 6, if you're not sure what happens when you subtract a negative, please put it in your calculator. 4 minus a negative 6 would be positive 10. All right, then you would divide both sides by negative 1. Y equals negative 10. All right, so that is my y coordinate. So I'm still looking now for my x coordinate. So you can use your original equation, your other original equation, or either one of the two that you multiplied. So any of the equations you like best, go for it. I'm going to use this first one. 3x plus 2, not y, but negative 10, because that's what y is. We solved it. So times negative 10 equals 1. All right, go ahead and solve this. I'm going to bring down my 3x. That would be negative 20. So I'm going to add 20 to both sides. 3x equals 21. Divide both sides by 3, and x would be equal to 7. All right, try the next one. If this is a good time for you to push pause and try it on your own, you should. But this is where we're going to multiply both equations by anything you want, really. But I chose two different ones in the last one. So go ahead and push pause and try this one on your own. Or if you're not ready, you can watch me do it now. 4x and 3x, last time I did 12. So I'm going to do something different this time. I'm going to get my middle terms to be 6 and negative 6. So I can get 3y to be 6y by just doubling this one. And I can get negative 2y to be 6, negative 6y by tripling this one. So let's start by distributing 2 times the first set of parentheses. 2 times 4x is 8x. 2 times 3y is 6y. And 2 times negative 19 is negative 38. All right, now I'm going to distribute this other one, and I'm going to line it up underneath my new equation. 3 times 3x is 9x. 3 times negative 2y is negative 6y, and I can see those are going to eliminate. So keep going. 3 times negative 10 is negative 30. All right, again, you have to decide if you're adding or subtracting. If these are already opposites, you can cancel them by adding. So 8x plus 9x is 17x. These 6y and negative 6y will eliminate. And negative 38 plus negative 30 should be negative 68. All right, divide both sides by 17. X equals Negative 68 divided by 17. Negative 4. All right, so half of my answer is done. I've got negative 4 for my x coordinate. Now I just need to keep going to solve for my y. So choose any of the 4 equations you want and rewrite it using negative 4 for x. So 4 times negative 4 plus 3y equals negative 19. All right, that would be negative 16 plus 3y. So I'm going to add 16 to both sides. 3y would be equal to negative 3. Divide both sides by 3. Y would be equal to negative 1. All right. The last part in today's lesson is finding the number of solutions. So sometimes what you're going to find is there aren't exactly one place that they intersect. So think back to our previous notes. If you had a line and when you graphed it, you graphed the other equation and it was exactly the same line on top of the other one, that meant that they didn't just meet in one spot like this one did. It would mean they meet everywhere, which is called infinitely many solutions. But what does that look like when you're solving it by elimination? So let's try and see. Let's line these two up and eliminate something. So I'm going to choose to get the 3y to be a 6y because then I can subtract it. So I'm just going to double the second equation. So 2 times x would just be 2x, and I'm going to line it up underneath this one. 2 times 3y would be positive 6y, and 2 times 9 equals 18. So now that they're lined up, my 6's are the same. I'm going to choose to subtract so that those would go to 0. But look what happens. When I subtract 2x minus 2x, those eliminate. When I subtract 6y minus 6y, those also eliminate, leaving me with 0 on the left. What about 18 minus 18? That is also 0. So when you're left with a situation where both of the variables drop out, you need to look at this problem and ask yourself, is this true or false? If it is giving you a true statement, that means that these two would line up and it would be the exact same line on top of the exact same line, which means it would be infinitely many solutions. Infinitely many solutions, I abbreviated that. However, if it's false, let's say I had 5 equals 0. If it is false, that would mean those two lines would never intersect, meaning they are parallel, which would mean no solution. So let's take a look at what we came up with. 0 equals 0. Since clearly 0 does exactly equal 0, this is a true statement, which means this type of situation would be infinitely many solutions. And that is our answer. There is not one coordinate that you would circle like we did on all the other problems today, because these are problems where they intersect in exactly one spot. These are examples of lines that intersect everywhere if it's a true statement. So the answer to this one is infinitely many solutions. Let's do one more just to make sure you understand this other part. So, I can go ahead and eliminate just by lining these two up. So I'm just going to bring this second equation down here. So negative 2x plus 5y equals 12. Okay, in order to eliminate, I would need to subtract, because if I added, let's just double check, negative 2 plus negative 2 is negative 4. And I don't want that. I want them to eliminate. So by subtracting, I've got negative 2 minus negative 2. If you don't believe me, let's look. Negative 2 minus negative 2. They eliminate. It's 0. So by subtracting, these eliminate. 5y minus 5y is also 0. So those eliminate too. So here's another example of where all of our variables dropped out, leaving 0, leaving nothing. On the right, 7 minus 12. 7 minus 12 is negative 5. So let's ask, true or false? Does 0 equal negative 5? No, it does not. So this means 0 does not equal -5. And if it's a false statement, that means this is an example of two equations that have no solution. They would be parallel if you graph them on a graph.